Yeah, thanks, Mike. Yeah, g'day everyone. It's great to see so many new faces, and um, uh, yeah, I hope you enjoy. Yeah, so as Mike said, I'm going to talk about um, the much anticipated set-theoretic type system for Elixir, and yeah, what's available now in the latest version of Elixir 1.17. Yeah, for those of you who don't know me, I'm Rob. I work for Alembic. I'm a senior consultant doing lots of live view Ash framework and back endy and a bit of front endy Elixir work with a tiny bit of GraphQL and JS and TypeScript as needed. And yeah, I live in Brisbane. So yeah, just a summary of what I'm going to talk about. The this much anticipated set-theoretic type system has or at least the first version of it has dropped in Elixir 1.17. It's a constrained and cautious introduction of compile time type checking into the compiler. Would be a good single sentence summary of what it is. It reworks some of the existing compiler warnings that previous Elixir versions had around types, and it also adds some new capabilities on top of that. And essentially, from what we get in this initial version, the kind of way forward, apart from waiting to see what happens next, what more news we might hear from Jose and the team working on the type system might have for us at Elixir Conf, etc. It sort of the immediate thing is that it reinforces the practice of asserting the shape of data in pattern matches inside functions. That's the real sort of, I guess, power or benefit that it brings, is that these, and I'll explain what I mean by this, but that practice is only going to help more, and only going to be helped more by the type system as it evolves and grows. So yeah, the agenda, talk about where we were with Elixir prior to 1.17 in terms of type systems, define loosely and at a very high level what is meant by a set-theoretic type system. I'm not a type theorist or programming language theorist by any means, so I'm not going to delve too much into the theory. But yeah, we can talk about what it is at a very high level. Overview what it provides, jump into a Livebook that has a whole bunch of examples that I've put together about how the type system works, and then wrap up with a brief discussion of what this gives us and what we should do about it. So Elixir, like any programming language, is typed. It just happens to be dynamically typed. So meaning that variables can, the types of variables can be unknown at compile time, but a program can still compile and may still run most of the time. But it's not, we don't strictly know at compile time the type of all the values in our program. And it's also, Elixir is also strongly typed, so we can't coerce values. When it comes to type checking, we're really concerned with, is a language dynamically typed or statically typed? But yeah, Elixir, like Erlang, is firmly in the dynamically typed camp as it stands. But given that, we can still make many inferences, and they could be inaccurate or incorrect about types and the compatibility of different variables. So here are some examples in Elixir We know as a human, and the Elixir compiler already knew that age is of type integer. It can reason about that at compile time because it's statically known. Even without this type system, we can make an assumption that full name, first name, last name are all binaries because we're appending them together. We can assume that the age field of this person struct is an integer because we're using, or maybe a float, but because we're using the plus operator. We know that the map Ashley only has one field called first name. So trying to access last name should be a compile time warning. And indeed, even without the new type system, it is, the compiler knows that completely what the type of that map Ashley is. And we should be able to reason about the fact that the map result is some map with some other unknown fields, because we don't know what other person is, but with an extra field that we do know, first name, and that's going to be of type binary and has a static value. So these are all inferences that we can already make, either as either the Elixir compiler knows that, tooling around it, the Elixir compiler know that, and we as humans reading the code can know that. And furthermore, we can tell tools and other humans reading our code our intent using the type spec language that we get from Erlang. So there's very limited use of type specs in Erlang, the compiler, but we have tools like Dialyzer that can use it. So here a human can read this code and see that, okay, there are two problems here because we're not wrapping up our result in OK or error. We're not tagging them in those tuples, and a tool should be able to work that out by analyzing the code. And yeah, but like I say, we have tools that can look at that. The most popular one being Dialyzer, which is a form of success typing, which means that it assumes the program is correct unless it can prove that it is incorrect. So it gives the programmer the benefit of the doubt. And then there's another tool for Elixir called Gradient. Both of these actually work for Erlang and Elixir. Gradient is a form of gradual typing. It will only check where types have been annotated. Otherwise, it assumes a dynamic type. A bit like what TypeScript used to be, I would say, at a very high level. The TypeScript type system has probably evolved a bit more than that, and it involves other things as well too. But yeah, they're the sort of two main tools that we had outside of the compiler. Then at runtime, there are heaps of tools that we can do to verify the shape of data. So we had a previous talk by Nick on type check. There are other libraries like Norm. You can validate data with Ecto, Ash framework, and there's a whole range of other tools that parse or validate data, conform data to a particular types at runtime. But here we're really talking about what can we do at compile time statically with our code. So no strictly type checking tools were integrated into the compiler, even though the compiler produces a lot of warnings and catches a lot of the things that the new Set-theoretic type does in its form does catch. There wasn't anything that's strictly a type checker really in this, or part of a type system until now, of course. So yeah, the much anticipated Set-theoretic type system came in. It's been talked about for a couple of years, and it's a collaborative effort between the Elixir core team, researchers, and industry. Anyone who's been following it will know these names. Guillaume Dubois is a PhD student. He's apparently now at Remote, and Remote have been supporting his efforts. Giuseppe Castagna is was supervisor there, and I believe he's at the French National Centre for Scientific Research. And there's been various industry supporters, Dashbit, of course, and a few others. And there's a great set of docs on Hex docs, including a link to a paper that sort of outlines the theory and goes into the sort of the theoretical underpinnings of this set-theoretic type system. We won't delve into that, but I encourage you to have a look if you're so inclined. So what is it? What is this thing called a set-theoretic type system? So at a very high level, and like I say, this is high level and imprecise. We're not going to go into the theory, but at a very high level, a set-theoretic type system is a system where types are treated as sets of values. So for instance, the type integer is a set of all values or terms, in this case, Elixir, that represent integers. And then we type variables in our program as some set theoretic expression of the base types. So we have set theory operations like unions, intersections, and negations. And then from there, we can type a variable based on that. So we could, for example, have a variable that is of type integer or Boolean, meaning that it could be any integer or any Boolean. And furthermore, another aspect of set theoretic type systems is subtyping. And again, it goes back to set theory. So type A is a subtype of type B if A is a subset of B. So for example, you could have the set of all maps, and then if you have a map that has particular fields, particular keys, particular values, that would be a subset, and therefore a subtype. And supposedly, using a set theoretic type system is more natural and flexible to introduce as a gradual type system for existing dynamically typed languages than the theories such as Hindley-Milner type inference and algebraic data types that you might find in languages like Haskell, etc. But again, I'm not a type theorist. We don't need to go there. And there's many, many more features, if you look at the paper, that make set theoretic type systems appropriate for adding a gradual type system, or gradually adding a type system to a dynamically typed language. So the documentation provides the classic example of negation as how this could apply to Elixir. So we have a negate function that if it's provided integer, multiplies it by -1. If it's provided Boolean, it negates the Boolean. This set theoretic type system, that would be typed as integer to integer and Boolean to Boolean, meaning it has to work on all integers and all Booleans. In the case of a function like this parse int function, which takes a string and attempts to parse it to an integer, we either get an integer or an error back. So the type is binary to integer or error. So yeah, and then finally, we can use negation to say, if we have a function convert that we want to take a string and return an atom, but there's a reserved atom that we don't want to return, we can say atom and not reserved. And reserved would be an example of a subtype of an atom type that's a subtype of the overall atom. And finally, there's a concept of a dynamic type, which allows for the gradual introduction of a type system of types into an existing program that's not statically typed. So again, the documentation on hex docs uses this example of integer to string. If for some reason the variable that we're passing to this function is typed atom to integer, this shouldn't type check, because integer to string only accepts integers. Whereas if we somehow are able to wrap the type, or make the type of the argument dynamic, it will type check, because dynamic says that only some subset of the type needs to match the required type of integer. So in this case, it will check or pass the type checker. So yeah, given those examples, what do we get specifically in the latest version of Elixir? So all the base Erlang types are modeled in the new type system. So integers, floats, maps, lists, tuples, functions, PIDs, binaries, you name it. They're all in there. And there's a limited number. One of the interesting and useful aspects of languages like Erlang and Elixir is there's a fixed set of types. Makes things easy to reason about. But so all of them are in there, but some of them are indivisible for now. So all lists, no matter what they contain, are all of type list. All tuples are just tuple, and all functions are just function. So there's no distinguishing lists that contain different types of elements or different numbers of elements, or same with tuples. And there's no distinguishing functions that have different return types, take different arguments, and have different arities. They're all the same. Maps are in there, and they can be either open or closed. I'll get into what that means, but effectively, open means that there is we don't know the full type. It's not statically known the complete type of a map. There could be optional keys effectively, whereas closed, we know all the keys. And a struct would be an Elixir struct would be an example of a closed map in this type system. And in this version, type checking is limited to pattern matching and comparisons operations within the same function. And it's also does provide some checking for misuse of functions, binary pattern matching, and exceptions. Also still within the context of just looking at a single function body. All right, so given that overview, let's go over to this live book that I have and go through some examples. I'll just make sure that all the outputs are erased. So this live book is running Elixir 1.17 and OTP 27. Just to ensure that there's nothing up my sleeve. So as I said, all types are modeled. And in this example, we're doing some stuff that you would never do in a real program, just to show the warnings that are emitted. And it should be noted that most of the type errors that we're going to get here, which surface as compiler warnings, would have been detected in the previous version of Elixir, but we now get better warnings in that we see more information about the type system coming through. So yeah, let's have a look. So I'll just evaluate this block, and we can see Livebook has a nice feature where it's going to give us the compiler warnings. So here we've got a string and a integer. We can't match them together, and we get this error about incompatible types. So that's actually straight from this error is the same, I believe, as Elixir 1.16. And again, this error is the same. The compiler knows that these matches don't work, but let's have a look. Yes, here is where we start to see some different compiler errors. I'll just scroll down. We can see in this in this tooltip that we've got expected type dynamic and very similar to what we had before, but from previous versions of Elixir. But yeah, things like the dynamic type are coming through. And Interestingly, the you can see here the pineapple on pizza field is 200 divided by 2. The type system doesn't know what that means. So this is sort of highlighting alluding to a limitation in the current version of this type system, in that a lot of operations that are really functions are blind to types. They don't propagate type information, and therefore we can't infer. So instead of a float, which pineapple on pizza should be, it just says term here instead. And again, we have more match errors working on structs in this stage, in this case, and again, that is not very. Sorry about the pop-ups there, but again, the compiler already knew this. The compiler already knows that there's a problem here with the two types. Oh, sorry. In fact, I didn't read this comment here. The Elixir 1.16 doesn't detect there's a problem. That there's a problem here, that we can't match a tuple variable to a function. But yes, and it also is highlighting the fact that fun and tuple are those indivisible types. You can't break them down any further, so we can't see that the Brooklyn tuple is actually a pair with a string and a float in this example. All right, moving on to maps. So as I said, they can be open or closed. Closed maps where we know all the keys and all the values statically. Open maps are where we might have optional key value elements in there. And yeah, the type checker can warn when we try to access non-existent keys of closed maps when we use the dot syntax. So if I run this, you can see here we've got Ashley has first name and age. If we try to access last name, we get an error, a type error. And 1.16 again would already know how to find this. Interestingly, neither 1.16 or the new type system works with the bracket access syntax, and so probably because the semantics are subtle, if we let this through to actually run, it would be a runtime error. Whereas if we let this function run, the return value here is nil. So the semantics are slightly different. The compiler doesn't let that through. So it could be argued either way whether we want to do that or not. So there may be a conscious decision that there is in the new type checker. There's no warning here. And then on this one, again, we are trying to do a pattern match on a fully known at compile time map with a key that doesn't exist, and the compiler sees that, and it knows that this dynamic with last name, with one known, what it thinks is a known field last name, is incompatible with something that only has age and first name. So that gets caught there. But as soon as we do anything like pass maps into functions and try to get them back, we get nothing with the compiler. the compiler is completely unaware of what map.put takes or returns from a type checking perspective. But dialyzer would have caught this. Similarly, if we use this constructor syntax or whatever this is called, I forget the particular name of it, comprehension. Again, this is invalid. There's no field called hobby to update on Ashley, and furthermore, what are we showing here? Ashley now is has gone from, at this stage, being fully statically known to now being a dynamic map, and we know nothing about it. We just know that because of this syntax, it is a map. Dialyzer would have caught this, and if you didn't have dialyzer and you let this through, there would be a runtime error. And if we have a map that's pattern matched in as an argument to a function, again, the compiler doesn't treats this as a dynamic map. It doesn't know. It only knows that it must have age and first name for this function to have pattern matched and run. It doesn't know about whether there's a last name or not, so it lets it through. All right, so struct's a special case of maps. And yeah, therefore it can infer keys and values, just like with maps. And yeah, if we have this person struct module with first name and age, it has a little function. We'll use this in future examples. So again, like maps, the compiler now knows that a person doesn't have a last name. It only knows that it has age and first name for sure. So there's an error there. It doesn't. The same applies if no values are set on the struct. They just happen to be nil, typed as nil by the type checker, and yeah, we do. It does know about the types of fields in structs. So if we try to concatenate the string 1 to excuse me, an integer, it knows to complain about that. So one thing, as noted, the type checker doesn't consider type specs in this version, and for any types to be inferred, they have to be as part of some kind of pattern match. But the big caveat with this version is it's only within the same function body. As I've said, the type checker doesn't infer return types of functions, unfortunately. So again, any of the errors here, the previous version of Elixir already could do this, but yes, if we've spec'd up this function so that we say yes, the person, the argument person is of type person, which is our struct from earlier. The type checker doesn't warn. The previous version of Elixir won't warn, but Dialyzer will catch it. As soon as we pattern match, though, we can pattern match on arguments. That's okay, because we're still sort of in the same function here, or the scope of the same function. Then we do get an error. But again, if we somehow construct a person through some function, so we have a function that returns a person, the compiler and the type checker don't know anything about build person, they can't type it, therefore last name, which doesn't exist, is let through because they don't know for sure what the return type of this person build person function is. But dialyzer knows, so that's that does highlight a sort of a big, I guess, limitation of this version. But if we call that function and we assert the shape of its return type here, then the compiler is happy to say, okay, this is a person. Person doesn't have last name, so that's a warning. That's a type error. And even if we however, if we call a function that doesn't actually return a person, so build person does, but this not a person function doesn't, it just returns an atom, the type checker doesn't, even though we've asserted this, it doesn't know that we're actually not returning a person. So it happily allows us to try to access a field that does exist on person, but wouldn't exist because this person variable is actually just an atom at this point. And again, dialyzer does catch this this situation. So yes, this limitation of being within the same function body is it's it's fairly profound for those of us who want to really get started with lots of type checking and lots of static type system checking for our programs. But we can't make any assertions or inferences based on the return types. And the same goes for if we were to pass in function arguments between different functions. So if we have a whole, in this example here, we've got a whole bunch of struct modules, and we have a function called do something, which takes either a foo or a bar, but it doesn't take the baz. There's no implementation for that. The compiler happily type checks this and allows us to pass in something that's going to crash at runtime with some form of function clause error. And again, while the compiler can't find this, can't sort of see that there's a union here, and sort of in the set-theoretic world, you could imagine this would be typed as foo or bar. The compiler can't see that, but again, dialyzer does catch that. So moving on, another interesting thing that the type system has brought in this version is certain misuses of functions and function call syntax. So if we have sort of an unknown, unmatched variable here from an argument, the compiler can't do anything with it. Interestingly, we've got these two things we're saying, okay, arg is either a map or a module, and there's a function on that map or module called myfun, try to run it. Given that piece of information, dialyzer is fine, but then we're also saying that, okay, arg itself is a function, so call that. Dialyzer realizes that this is a contradiction and will warn on line 4 and say there's something wrong here. So that gives a bit of insight into how dialyzer is working, in that it's trying to unify different facts that it knows about your program. And at this stage, it's much more sophisticated than the new type system. And yeah, this is the error that dialyzer throws. But yeah, I thought that was interesting how dialyzer works there. However, in some more statically inferable cases, the compiler says no, value is a type integer. It can't have a function on it because we're expecting value to be a module, but it's not. Similarly, it also knows in this case that value being 2 is not a function, so you can't call it. And these warnings are very similar between 1.16 and 1.17. In this case, 1.16, 1.17 would both catch that there's no such function on the module person as bad, so it will warn. And again, because the checking only works within the body of a function, as soon as we try to construct a module at runtime through a function, the compiler has no idea and lets that one through. So moving on from functions, another feature of the new type system is some warnings around comparisons. So the type checker warns if there's a comparison between incompatible types. But interestingly, the equality operators double equal and triple equal are not considered comparisons. And I think this is a conscious decision because they do behave a little bit differently to some of the other comparison functions built in, greater than, less than, min, max, etc. And the integer and float types are considered compatible, which is a known thing in Erlang and Elixir. So if we look at some of these examples here, we can see that comparison between these incompatible types produces a warning, whereas it wouldn't have in 1.16, because Erlang and Elixir, they have a total order of all terms, or all terms can be ordered, and that's what the comparison operators use. But so this would still run at runtime, but I believe, but the compiler is now warning us that we know that these two things are not compatible types. One is a binary, one is an integer. You can't compare them together. And but there are no such warnings for the double equal or triple equal operators. And but again, interestingly, dialyzer knows that these are contradictions, that these expressions will always produce false, and will warn appropriately, because the contradictions are not, or tautologies are not useful. If we look at the case where we're comparing different but compatible types, in this case an integer and float, there are no warnings from compiler in either version of Elixir or dialyzer. And the known gotcha with the double equals is that 42 and 42.0 are considered equal in Erlang and Elixir. But the triple equal does know that they're distinct. So yes, upon learning that, one is compelled to add spray a whole bunch of extra equal signs into their tests and code to defend against that problem. Yes, and I've shown what the outputs are there, so that's an interesting difference there with compatible and incompatible types. All right. Along with basic type comparison, struct comparisons also get some mention in the compiler. So if one or more structs is involved in a comparison, the type checker will warn, even if you might be doing something that kind of makes sense, like two structs that are exactly the same value, for instance. So here we have one struct and one map. The values of the fields are the same, of course. In memory, they are going to be different because the person, the Ashley variable, is going to have an extra key, with because it's a struct. But the compiler starts to warn. And if I can scroll down to get this error message, it says down the bottom, comparison operators perform structural and not semantic comparison, and comparing with a struct won't give meaningful results. So this is the case where one struct is in the comparison. Here's an example where there's two structs, they're different values. Again, it won't. It will complain, even though you could potentially argue that Ashley older should be greater than Ashley, maybe. It's probably a bit of foot gun. And even if the two variables are exactly the same value, it will still warn. And again, this could potentially make sense, but probably not. So I think it's fairly wise that they've just made that blanket rule that you can't compare structs with other terms, even if it's a struct of the exact same value, and it potentially could know that statically. So yeah, I thought that was interesting. All right, so yeah, thank you for bearing with that demo. That's the end of the sort of the examples that I want to show. So I'll try to go back to here and wrap up. So yeah, what did we see in those examples? We saw that all types are modeled in the type system. A lot of the existing type warnings that are not strictly from a type checker or a type system get replaced with slightly better warnings. We see that we can get type errors when we're pattern matching statically known incompatible types, when we're accessing non-existent keys on closed maps or structs. We can see errors when there's invocation of non-existent functions, when we try to compare incompatible types, and when we try to compare structs, any kind of struct with any other term, even if it's a term that has exactly the same value. There are a few little features in 117's type system that we didn't cover, along with trying to invoke functions that don't exist. There are warnings around capture of non-existent functions, which is kind of the same. There are warnings around building and pattern matching on binaries. And I ran out of time to do examples for that, but the documentation does briefly cover that, and some use of exceptions in rescues that also will warn. Oh, my apologies. There's two slides on the same page there. So what are the limitations with this really as it stands in 117? So the big limitation is that inference only happens within the body of a single function. Yeah, any kind of unmatched argument or return type is effectively dynamic. Another big limitation is that types like lists, tuples, functions are indivisible. They have no subtypes, and there's no way of annotating types. So to demonstrate my examples using the pin operator and matching is kind of a hack to be able to force the compiler to tell me what type certain things are. So, and there's talk of there's been talk in the past of type annotations using the syntax that I talked about before, integer and Boolean, prefixing that with a $ and using something that's almost looks like type specs, but not quite. And the $ is a reserved, it's unused operator symbol, whatever it happens to be in the Elixir compiler. So Jose has talked about keeping that around for this case, for a case like implementing a type system. Didn't use the $ for anything else in Elixir already. So given the version of the type system we have, how should we proceed? So we for most of us, we can probably wait and see what happens. This is a constrained and cautious, dip the toe in the water implementation. It's not hugely powerful. Gives us a bit of an idea what they're up to, but maybe we can hold out, see what they're doing next, and decide if we want to change anything about our programs based on that. But in the meantime, the type checker does reinforce a couple of things. I have mentioned one here in the slides, that it's always, it seems to be better at least from a type checking and a type safety perspective, to always provide as much information to the compiler about what we're expecting or asserting the shape of our data to be. So for instance, we've got this age function where if that person was we're trying to pass in a person struct, and then but we're not matching on the person struct, and we try to use a field that doesn't exist because we've got a typo. We've got AEG instead of AGE. There's no warning. But if we put if we match person in the person struct in the function argument there, we'll get that compiler error. Similarly, if we have some function that returns something and we know what that type should be, we can make some assertions there. And even though we saw an example where you could abuse that, and if it doesn't really return a person, it'll accept it. If we are sure as a programmer that make person returns a person, we can help the compiler by and the type checker by matching on the person struct there. And the other thing I think it reinforces is that if you bought into Dialyzer, continue using Dialyzer, because Dialyzer at the moment picks up a lot more than the type checker does. So yeah, this there's not, because of the things like comparisons and some of the new things that the type system is doing, it does give you more, but you're going to get the best experience, I think, if you use 117 and Dialyzer together. You're going to catch as many problems as possible. I haven't looked at what my examples look like in something like Gradient, but I would say the same thing applies. Gradient is probably going to be more sophisticated at this stage. All right, that was all I had. Thanks for bearing with me, and that was a bit heavy in some walls of text, but hopefully that was interesting. And yeah, if anyone's got any questions, happy to have a chat.
Awesome. Thanks very much for that, Rob. We do have a couple of questions in the Zoom chat. Why don't we start with Mateus's question? Why in non-existent key 3? I think we might need to go back to the live book for this one. It's set as dynamic instead of a closed map with only a single field.
That was in
Yeah,
that was this one here.
yeah,
That
it
was
was
this one here.
non-existent key 3.
Yeah. See if we can get that that pop up to. There we go. Sorry, yeah. What was the question again? I can't see the
That's
chat.
okay. So you see in the but got type, and then it shows dynamic with a map. Um,
Yeah, my question arises from the fact that in one definition of a map, the compiler defaults to a closed one with 2 fields. And another one, it's the same definition of the map, but it defaults to a dynamic map, even though you define it with the same syntax, with only 1 field.
Right. I believe that this is to do with the left-hand side and right-hand side of a match. So I believe on the left-hand side, because you can match on a subset of the keys in a map. It doesn't know what the type of this left-hand side is. Yeah, we've got some kind of map, and the only thing that we know for sure about it is that it should have last name as a field.
I see.
Yeah. Whereas on the right-hand side, that's like in this match is a concrete type. So yeah, I believe that's the reason that it types that way.
Perfect. Yeah.
yeah,
Thank you.
I find that very confusing that there's a type error on a pattern as opposed to on a value. But that seems to be how it reads here. Yeah. They got their work cut out for them in improving that error message.
Yeah, that's right. So and that's why I think in some parts of the presentation or this doc I've said better warnings in quotes. There's potentially some more information there, but it's a bit like dialyze. You have to sit and think about it for a while. But yeah, that was actually a great question, because yeah, I didn't appreciate that myself until just then. But yeah.
Yep. Okay. And then a couple from David. Are there plans to allow functions to be analyzed to allow inference?
Yeah, like
yeah.
in the future. I just haven't been
Yes.
keeping up on the discussions on that.
Yeah, no worries. Yeah, that is something that I probably should have mentioned explicitly, is that they do, like all these things, they do plan to extend. So your all those indivisible types will become divisible in the future. Because they focused on maps, and I think there was another sort of type that they really focused on in this version, because maps are probably the hardest, but to get right, I think. But definitely there's going to be more analysis of those types within function bodies, and then the argument types and return types for functions, so that you can infer between them. Because I mean, yeah, it's a major limitation. It's almost unusable as it is without that, because you can trick it so easily.
I guess that's why they're using the term gradual a lot.
Yes, well, that's right. And in the paper, in the academic paper, they use some clever language, because they say they're gradually introducing a type system to Elixir, and the type system that they're gradually adding is a gradual type system. So yeah, a bit of a pun there, but yes, it's very incremental, and I understand why they're doing it, because there's they don't want to break things. This would need Elixir 2 if they wanted to do a big bang. So by doing it this way, it's a lot safer. But it's everyone who's been hanging out for this for a decade, or for some kind of type system for a decade, and especially since there was an announcement of actual work, this is nothing but a little teaser, really.
And the next question I had, which was in the section where you were talking about no inference, there was one of the examples you had there, which was like foo or bar. I really didn't get that one.
Let's have a look.
Like, you know, just it's always best to assume that I'm an idiot.
So this one here.
Yeah. Like, so you were saying that should be caught even with 1.17 in its current state, but I didn't really understand why.
Oh, sorry, no, that's my I apologize if I gave that impression. No, this is not something that will be caught in 117. Yeah,
Or in dialyzer.
I know dialyzer does catch this.
Okay, so that's the bit I don't understand.
Yeah, so dialyzer.
It's Baz. Okay, sorry, I'm an idiot. Right.
No, it's all good. Yeah. These sometimes I wonder about this one. Foo and bar are distinct enough, but yes, yeah. So this is a third struct that doesn't have an implementation and do something. But So the dialyzer knows it looks at your whole program, and it knows that really the argument type for do something is a union of foo and bar, and then if you specify that, it will then make sure that that you're not telling lies there as well too. But I believe even if you didn't have that spec, it could work that out. But yeah, the type checker.
I just missed the Z. So
no worries.
Who knew? Typing errors could cause bugs. And then the third little thing that I added, which is just a continuation of the first point we were talking about, is the plan to like absorb as much as dialyzer currently has where it's appropriate, or is it a different animal altogether?
My understanding is that there isn't, but I don't like. I've listened to a couple of talks and podcast episodes, and I don't where they've appeared talking about the type system. I don't recall there being anything there. So yes, it is one of those elements of uncertainty. If you're not already bought into dialyzer, should you bother? I think probably in my experience, because I haven't been burnt too badly by dialyzer, there's still time for it to be useful in an Elixir code base. That proposition could change in a year if we're like 2 versions of Elixir down the track or something, and they've really extended this a long way. Maybe dialyzer can be superseded. But yeah, in terms of specific plans, I'm not aware of anything. Good question to ask them if anyone's going to the conference. Ask Jose about that. But I mean, dialyzer my understanding is it's a pretty it's a pretty big engineering effort. It would be a shame to throw that away. And I hope that if there's type annotations get added to Elixir, the dollar syntax or whatever it becomes, that some way of getting that into a state where dialyzer can use that is still possible. But short answer is I don't know.
Rob, can you remind everyone what the dollar syntax is? Because I think I saw it once, but I can't remember.
Yes. So if we have that negate example that they like to use, and let's see, and we've got the same thing. The dollar syntax they're proposing is that you could annotate this function to be something, and I'm not 100% sure if this is right. The double colon thing would be something like integer. And I'm probably missing some parentheses here.
Doesn't that get an or?
No, it needs to be an and, because sorry. Yes, and this is the other confusing thing, is that it needs to be an and, because this is the type of the entire function. Yes, you've got to be able to accept integers or booleans, but the type of this function is a function that can accept integer and return an integer, and it has to be a function that given a boolean returns a boolean.
That gets extra confusing because it's a negate function, and really what they're talking about is De Morgan's law for logic, where not, yeah,
well,
that is.
Yeah, that's right. So there are some some of the things that get talked about in the documentation, not necessarily the paper, because that goes right off the deep end. But in the documentation, you do see allusions to that, where things are getting rearranged and like normalized. But yeah, really the dollar syntax is just this, that if we want to annotate functions rather than using an @spec, it'll be $, and this gives them the ability, I believe, to have a slightly different syntax to how this works here. I'm pretty sure like and is not a part of is not a part of the type spec syntax. But yeah, and what I was saying is that dollar isn't used anywhere in Elixir currently. Yeah, Jose was keeping that up his sleeve for just such a eventuality. So that's what they're proposing to do. But hopefully there's some tooling that will go from this form to something like this, and other tools see that. But yeah, I haven't heard anything to that effect.